Imagine, just for a second, looking up into the daytime sky.
Okay.
But instead of seeing, a thin canopy of blue air scattered with white clouds, you are staring up into this suffocating, incredibly dense, murky ocean of gas.
Right, something totally impenetrable.
Exactly. And it stretches 1,000 kilometers straight up into space. Now look around you. There are no oceans,
None at all.
no mountains either. There is no winter, no summer. The entire planet is wrapped in this perfectly solid, 50-kilometer thick shell of unbroken granite,
Like a vault.
like a giant vault. Yeah. And the surface is just, well, it's nothing but an endless, steaming, shallow swamp.
It's an incredibly bleak picture.
It really is. I mean, welcome to the ultimate evolutionary pressure cooker.
Yeah, it is a profoundly alien image of our own planet. Because, we are so conditioned by the standard models of geology and biology, right?
Sure.
The slow drift of tectonic plates, the gradual climate shifts. So picturing Earth as this sealed, static vault, it feels almost claustrophobic.
Claustrophobic is the perfect word. And today, we're doing a deep dive into a theoretical framework that takes that exact claustrophobic image and builds an entirely different biological universe out of it.
Yeah, we're looking at a self-published manifesto called The Small Bang Theory.
Or SBT.
Right, SBT, authored by Art Michael Meyer. And I have to say, the format of this text is honestly as wild as its claims.
It really is.
It's essentially this massive, sprawling debate between the author and an AI named DeepSeek. And together, they attempt to entirely rewrite the cosmological, geological, and most importantly for us today, the biological history of Earth.
Which is a huge undertaking. But I want to be incredibly clear with you listening right now, just before we really get into the weeds here. Our mission today is not to endorse this theory.
Right. Exactly.
We're not weighing this against established peer-reviewed science to declare some kind of new truth.
No, not at all.
Our goal is strictly exploratory. We just want to step inside this alternate biological universe, this small bang timeline, and examine the internal logic of how its animal and plant life supposedly operates.
And the scope of Meyer's reimagining is just vast. He isn't just looking at, isolated anomalies in the fossil record.
Right.
He is proposing a single unified mechanical framework. He's trying to answer over 100 disparate scientific questions by assuming the Earth functioned under radically different physical laws until a very specific catastrophic event.
Yeah, so we're going to look at the origin of life in the sealed terrarium, the bizarre physics of his sluggish dinosaurs, the absolute terror of these alien mass extinctions, and the sudden emergence of what he calls deep-sea monsters.
It's a fascinating thought experiment in environmental determinism, honestly. If you accept the premise of this 50-kilometer thick granite shell trapping the Earth's internal heat, you have to completely reverse engineer how organic material would form and survive on top of it.
So let's start right there, at the formation of the terrarium. Standard cosmological models give us a cooling sphere of magma, right?
Right, which eventually forms shifting plates.
Exactly. But Meyer's theory suggests that as the Earth cooled around 541 million years ago, it didn't form shifting tectonic plates. It formed a complete, unbroken seal.
Yeah, the lighter materials, like the silicates and granites, they essentially floated to the surface of the molten rock and solidified into a single crust.
Like a skin on a bowl of hot soup.
That's a great way to put it. So imagine a spherical stone vault, maybe 20 to 60 kilometers thick, and beneath it, the mantle and core continued to churn, building unimaginable heat and pressure.
But on the surface, it's a different story.
Right, on the surface of this vault, temperatures drops just enough for water to condense out of that massive toxic atmosphere.
So water starts pooling on the surface of the granite.
Yeah.
But because there are no trenches, no rifts, nowhere deep for it to go.
It just spreads out.
It just spreads out everywhere.
Exactly. It creates a global network of very shallow, highly pressurized hydrothermal lakes and swamps. And it is within these specific, highly stable chemical sinks that Meyer argues life was forced into existence.
Right, and he credits this to something he calls the one rule.
Yes, the one rule.
It sounds like a law of thermodynamics. Like, how does he define that biologically?
He treats it almost exactly like a thermodynamic inevitability. Meyer argues that organic life is not a miraculous accident of lightning striking a puddle.
It's not just a lucky break.
No, not at all. The one rule states that any system containing self-replicating molecules subject to random errors like mutations will inevitably evolve into complex forms, provided the environment remains absolutely stable over vast stretches of time.
Wow, okay, so stability is the engine. Because the planet is wrapped in a solid granite shell, you don't have sudden volcanic fissures opening up under a lake. right? Or continents drifting into different climate zones,
Yeah.
wiping out that fragile early chemistry. These molecules have millions and millions of years of undisturbed, boring repetition to slowly build complexity.
And the text gets incredibly specific about the chemical sequencing of that
Yeah,
complexity.
the chemistry part is wild.
Meyer links the evolutionary ladder directly to the atmospheric and surface chemistry available at different stages of the Earth's cooling process. Early on, that 1,000-kilometer high atmosphere was unbelievably toxic.
Because it's constantly being fed by gases squeezing through the microfissures in the cooling granite, right?
Precisely. So if you look at the list of elements he cites, it reads like a metallurgical recipe. He says the earliest prebiotic life, the very first metabolic processes, relied almost entirely on sulfur and iron.
Sulfur and iron. Which makes sense if you think about the mechanism there.
Absolutely. In a high-pressure, oxygen-starved hydrothermal environment, early life couldn't use oxygen to breathe or process energy.
Because there isn't any oxygen.
Right, so sulfur acts as a fantastic electron acceptor in anaerobic conditions, and iron acts as a catalyst. These weren't just available, they were chemically necessary for life to function in that specific toxic soup.
But then, according to the text, the environment shifts. He mentions a progression to phosphorus and magnesium.
Yeah, because as the thick atmosphere continued to condense, you had these relentless global rains, and those rains began to wash the heavier, more toxic metals out of the sky and down into the shallow sinks, trapping them in the sediment.
So the chemical makeup of the swamp is actually changing over time.
Exactly. And this changing chemical reality forced life to adapt. Phosphorus and magnesium became accessible, and according to Meyer, this directly triggered the emergence of the RNA world.
The backbone of genetic replication.
Exactly. And he carries this logic all the way up to complex animals. He says zinc and copper become vital for cellular structures once oxygen levels finally shift.
And then for advanced creatures, right, the ones with nervous systems.
Yeah, suddenly you need calcium for cellular signaling and sodium and iodine for neural networks. He essentially views our current biological makeup, our nervous systems, our blood, our bones, as a layered historical archive.
We carry the chemical history of this cooling, filtering, pressurized Earth inside us.
That's his argument, yeah.
Okay, but that brings up a massive point of friction I have with his chemical timeline.
Mm-hmm.
Meyer proposes a completely different origin story for the foundational organic material of our planet fossil fuels.
Oh, the abiogenic origin of fossil fuels, yeah.
Coal, oil, natural gas. This is where his geology and biology really clash with what we know.
It deeply intersect in his theory, yeah. Because standard science tells us that coal is the squish remains of millions of years of dead swamp forests.
Right, and oil is ancient marine algae compressed into the oceans.
But Meyer completely throws that out. He says the Earth made these fuels chemically, all by itself, deep underneath the granite crust.
Underneath the 50-kilometer vault.
Yes. He relies on a known chemical reaction called the Fischer-Tropsch synthesis. In industrial applications, this process converts carbon monoxide and hydrogen into liquid hydrocarbons. Meyer argues this happened naturally on a planetary scale.
So we have a planetary oil refinery.
Basically. Beneath that vault, you have extreme, unrelenting heat and pressure acting on carbon-rich gases trapped in the magma. For hundreds of millions of years, these compressed gases are forced upward. They squeeze through the microscopic pores and fissures of the granite.
And the rock acts like a filter.
The rock itself acts as a catalytic filter, and the extreme pressure drives the Fischer-Tropsch synthesis. So by the time these substances reach the surface crust, they have chemically transformed into crude oil and coal.
Okay, hold on. I really had to push back hard on this.
I figured you would.
I mean, even if I accept the geology of a planetary oil refinery, what about the physical evidence? Anyone can go to a museum and see a chunk of coal that has a perfectly preserved fern leaf imprinted right in the middle of it.
Right, the fossilized plants.
Yeah, if coal is just a chemical byproduct bubbling up through the rock, how do we have billions of tons of actual plant and animal fossils locked inside it?
So Meyer actually anticipates that exact skepticism, and his answer relies on visualizing the surface environment we just described.
The global swamp.
Exactly. From roughly 541 million to 66 million years ago, there is no dry, varied land. The entire surface of the planet is a single, uninterrupted, shallow, global swamp.
So it's just a ubiquitous carpet of biomass covering the whole globe.
utterly ubiquitous.
Yeah.
Now, picture this chemically synthesized, highly viscous crude oil and coal sludge slowly seeping up through the surface cracks.
Okay.
Where is it pooling? It's pooling directly beneath and into this incredibly dense global layer of swampy vegetation.
I see where this is going.
Meyer argues that the plant fossils we find in coal are merely impurities.
Impurities, yes.
To him, standard science looks at the fern leaf in the coal and mistakenly assumes the fern created the coal. Meyer reverses the causality. He says the coal was already forming chemically from below, and the dense, swampy biomass simply fell into it, sank into the sticky, toxic tar pits, and became perfectly preserved impurities within a chemical mixture.
That is a staggering flip of perspective.
Isn't it?
The organic matter is just the garnish on a chemical cocktail. The earth mixed itself. And I guess because the swamp covered the entire planet, you'd find these impurities everywhere you find the seeping hydrocarbons.
Exactly. It allows his theory to maintain internal consistency. The biology doesn't create the geology. The biology is merely a passenger on top of the geological machine.
Okay, that sets up a fascinating transition to the animals themselves. Because if the environment dictates the biology, let's look at the environment these creatures actually lived in.
Because according to Meyer, this world was incredibly static.
Right, and the central biological thesis of the small bang theory is that a boring habitat creates boring animals.
Boring in this context, meaning organisms that lack the evolutionary pressure to develop complex, dynamic, or highly intelligent adaptations.
So let's lay out the parameters of this terrarium. We already mentioned the unbroken granite shell, so there are no tectonic plates crashing together to form mountain ranges. The surface is relatively flat.
It's extremely flat. Furthermore, Meyer posits that during this massive 475 million year stretch, the Earth did not yet have a moon.
Wait, no moon?
No moon.
So no moon means no significant gravitational pull on the surface waters. So no tides.
Exactly.
Yeah.
The waters in these global 500-meter deep lakes and swamps would have been incredibly stagnant. You don't have the dynamic coastal ecologies that tidal zones create.
Right, no tide pools forcing marine life to adapt to being exposed to the air twice a day.
And crucially, he claims the Earth had no axis tilt. It was spinning perfectly upright relative to the sun.
Which eliminates seasons entirely.
Yes. The equator was perpetually hot, the poles were perpetually cooler, but there was no annual cycle. Every single day was exactly the same as the one before it.
Just millions of years of the exact same Tuesday.
Exactly. And capping all of this off is that atmosphere, 1,000 kilometers high. The atmospheric pressure at surface level would be crushing compared to today. The humidity would be absolute. It's an endless, stagnant, high-pressure hothouse.
Okay, so now apply Meyer's one rule to that specific environment. If you are a creature evolving in a warm, shallow, stagnant swamp where the weather never changes, the food supply never fluctuates with the seasons, and there are no geographic barriers to force adaptation,
What do you become?
you become a dinosaur. Or at least Meyer's version of a dinosaur. He explicitly describes them as sluggish, blunt, and grazing creatures.
He really uses this environmental model to solve what he views as massive biological anomalies in dinosaur paleontology.
I mean, standard science does often struggle to reconcile the immense size and bizarre proportions of Mesozoic creatures with the gravity and physics of our modern Earth.
Right, the classic problem of the giant sauropods. A creature the size of an apartment building, weighing 60 tons, walking on dry land.
Yeah, how does its skeleton not shatter under its own weight? How does it pump blood 50 feet up its neck to its brain without its heart exploding?
Meyer places them in the water. Remember, the Earth is covered in these 500-meter deep lakes. He argues these massive, long-necked dinosaurs were not terrestrial giants stomping across dry plains.
They weren't walking around on land.
No. They lived entirely in the shallow waters, relying on the physical buoyancy of the water to support their immense mass.
So they're basically waiting. They use those incredibly long necks like snorkels or, to graze on aquatic vegetation deep below, or to reach low-hanging swamp ferns on the muddy banks.
While their massive bodies remain safely supported by the fluid dynamics of the swamp.
It's a very mechanistic solution to a biological problem. But the real ingenuity of his atmospheric model comes into play when you look at the flying dinosaurs, the pterosaurs.
Oh, this part is fascinating.
It really is, because this has always baffled me. You look at the fossil, the Quetzalcoatlus, it has the wingspan of a fighter jet, but the bone structure is relatively fragile.
Right, very light bones.
Aerodynamic models, based on our current thin atmosphere, really struggle to explain how these creatures could generate enough lift for sustained, powered flight, let alone take off from the ground.
Meyer argues that's because we're applying the wrong fluid dynamics. They weren't flying in air as we understand it. They were operating in an atmosphere compressed by a 1,000-kilometer column of gas.
So the air density would be immense.
It would behave much more like a liquid than a gas. Meyer suggests that pterosaurs didn't fly. They paddled.
They paddled.
Yes. It was less like aerodynamic lift over a wing and more like a submarine using hydroplanes to maneuver through a dense, resistant fluid.
That is wild. So they are essentially swimming through a thick, pressurized atmospheric soup.
Exactly.
They didn't need massive, powerful chest muscles for rapid flapping because the dense air provided incredible resistance and buoyancy. A slow, methodical sweep of those relatively small wings would propel them through the heavy humidity.
That completely transforms the visual of the Mesozoic era. It wasn't a world of agile predators sprinting across dynamic landscapes.
Yeah.
It was a sluggish, heavy, slow-motion world. Everything is waiting, paddling, or slowly grazing in this thick, unchanging greenhouse.
And it explains their cognitive development too, right?
Absolutely.
If there's no winter, you don't need a brain capable of forward planning. You don't need to develop complex migration routes or hoarding behaviors or intricate social structures to survive scarcity.
You just wake up, eat the swamp fern that is always there, and go back to sleep. Stability breeds simplicity. The biology perfectly mirrors the geology.
But a terrarium can be perfectly stable on the inside and still be vulnerable to the outside. Which brings us to the mass extinctions.
The alien bombardments.
Yes, because while the Earth is sitting there stewing in its own juices, Meyer's text claims it was repeatedly subjected to absolute devastation raining down from the solar system.
He fundamentally rejects the standard geological mechanisms for the first four major mass extinctions: the Ordovician, the Devonian, the Permian, and the Triassic.
Right? Established science usually looks to internal Earth processes, like massive volcanic events, the Siberian traps, gradual shifts in ocean chemistry.
But Meyer says the Earth couldn't do that to itself because the granite vault was sealed. The threats had to be extraterrestrial. But he doesn't just say asteroids. He claims these extinctions were caused by small bangs, catastrophic planetary explosions happening to other planets in our solar system.
It's such a violent pinball machine view of the solar system.
It really is.
Let's trace the chronology he lays out. The first major event is the Ordovician extinction, roughly 443 million years ago. He attributes this to the explosion of Uranus.
Yes, Uranus ruptures, and because of its composition, it ejects incomprehensible amounts of ice debris outward into the solar system.
I'm struggling to picture how an explosion billions of miles away targets Earth. It's not like Uranus aims a sniper rifle of ice at us.
Right, it's not a targeted strike, it's an expanding debris cloud. Think of it structurally. When Uranus explodes, it creates a massive, diffuse, expanding sphere of icy shrapnel. Space is vast, so this cloud spreads out over millions of miles.
Okay, so it's huge.
Earth, in its orbit around the sun, eventually intersects with the outer edges of this expanding cloud.
So it's not a single impact. We are essentially flying our terrarium through a cosmic minefield.
Exactly, and we might spend thousands or even millions of years passing through that specific debris field. For the Ordovician event, this constant bombardment of icy material entering Earth's thick atmosphere caused a catastrophic sudden global freeze.
But endless warm swamp freezes over for the first time in planetary history. That would be an absolute biological slaughter.
Oh, complete devastation.
If an organism has never experienced a temperature drop, it has no genetic mechanism to survive ice.
Meyer argues this acted as a brutal biological filter. The only creatures that survived were those that lived in the absolute deepest, perhaps geothermally warmed pockets of the 500-meter lakes.
Or early amphibious creatures that could retreat into the mud and lower their metabolic rates to near zero.
Right. Then, around 359 million years ago, we hit the Devonian extinction, and Meyer blames Neptune for this one.
Neptune also explodes, also sending ice. But because Neptune is further out on the orbital plane, the physics of the debris cloud change.
Exactly. The shrapnel takes longer to reach the inner solar system, so the cloud is much more dispersed and spread out by the time Earth flies through it.
So the frequency of impacts is lower, but the duration of the bombardment is much longer.
Yes. So instead of the instant, shocking freeze of the Ordovician, the Devonian event was a slow, agonizing cooling period that dragged on for epochs.
Which forces a completely different kind of adaptation. I mean, an instant freeze kills you before you can blink. A slow freeze starves you out as the ecosystem slowly degrades.
Marine and plant life had to painstakingly adapt to these creeping thermal changes.
And then we move from ice to fire. The Permian extinction, about 252 million years ago. Standard science calls this the Great Dying. Up to 90% of all species vanished. Meyer attributes this absolute catastrophe to a planet much closer to home, Venus.
Venus explodes, and because it's so close, the mechanics of the debris cloud are terrifying.
Yeah, because the material from Venus doesn't have time to disperse or cool down in the vacuum of space.
Exactly. When Earth intersects this cloud, it is bombarded by massive, glowing hot rocks.
The text mentions that the heat injected into the thick, pressurized atmosphere was so intense it literally incinerated the giant insects that had evolved to paddle through the dense air.
It was a global broiler. The glowing rocks striking the surface caused localized, violent melting of the granite crust itself. The shallow waters just boiled.
If you are a sluggish, blunt dinosaur or a specialized swamp plant, you have absolutely zero mobility to escape a boiling lake. You just perish.
You're cooked. And finally, the Triassic extinction 201 million years ago, blamed on Mars.
Which is a weaker version of the Venus event, right?
Yeah, Mars is smaller and slightly further away. So Earth passes through a cloud of warm but not glowing hot rocky debris. It causes localized melting and severe climate disruption, but not total incineration.
It acts more like an ecological clearing mechanism. It burns away the dominant specialized vegetation and fauna, leaving vast empty niches in the swamp for the surviving dinosaurs to eventually crawl out of the mud and completely dominate.
But, this string of alien bombardments raises a really critical question about the resilience of life in Meyer's model.
That's exactly what I keep coming back to. If the terrarium is getting subjected to millions of years of freezing ice, then boiling oceans, then melting granite, how does the unbroken chain of life continue? I mean, boiling water sterilizes things. Melting granite leaves nothing behind. It sounds like total annihilation.
The survival mechanism relies entirely on the margins. Because the Earth is passing through diffuse clouds, the impacts are not uniformly distributing thermal energy or ice to every single square meter of the planet simultaneously.
So there are pockets of lesser impact, microclimates of survival.
Yes, and the creatures that survive these localized hellscapes are never the dominant, highly specialized apex species.
Right. The specialists die because their specific swamp fern burned up.
Exactly. The survivors are the ultimate generalists. The scavengers, the creatures small enough to hide in the deepest mud, with metabolic rates flexible enough to survive on whatever scraps of organic matter remain when the bombardment finally ceases.
So the biological chain is severely bottlenecked, stretched to its absolute limits. But the text insists the global nature of the swamp allowed isolated pockets to hold on.
They hold on, they repopulate the terrarium, and they go back to their sluggish, grazing existence under the thick atmosphere.
Until the big one. Because Meyer makes it very clear that these alien explosions were merely external disruptions. The true crucible of evolution, the main event of this entire biological manifesto, came from the inside.
Yes, we reached the 66 million year mark, the Cretaceous-Paleogene extinction event, the KPG boundary.
The death of the dinosaurs. Standard science, obviously, points to the Chicxulub asteroid impact in the Yucatan as the primary trigger. A massive rock from deep space slamming into the Earth.
But Meyer's theory requires a completely different mechanism. Because remember, for 475 million years, the pressure cooker has been building.
The core of the Earth has been generating heat. The magma has been churning, releasing carbon gases, synthesizing abiogenic oils under the crust. The tension against the underside of the 50-kilometer thick granite vault has been relentlessly compounding.
And no physical container, no matter how thick, can hold infinite pressure.
Exactly. Precisely 66 million years ago, that pressure reached its critical physical threshold. The structural integrity of the granite shell failed. The Earth violently, catastrophically expanded from the inside out.
The small bang.
The small bang.
The rupture occurred primarily along the equator, where the centrifugal forces of the Earth's rotation naturally made the crust structurally weakest. The globe literally ripped open.
And the visual Meyer paints for the Chicxulub impact in this moment is incredibly audacious. Because he doesn't deny there was a massive impact, but he completely denies it was an alien asteroid.
Right. In the chaotic, explosive physics of the planetary rupture, the pressurized gases venting from the mantle were so incredibly powerful that they blasted millions of tons of the Earth's own granite crust straight up into space.
The Earth blew its own lid off.
Meyer claims the Chicxulub impactor was a gargantuan chunk of this ejected terrestrial granite. It was blasted into low Earth orbit, hung there for a period, maybe months, maybe years, and eventually orbital decay and gravity pulled it back down.
The ultimate planetary boomerang. Earth shoots itself and the bullet comes back down.
It's a great image.
But while a massive rock falling from the sky is bad, the biological devastation described in the text is actually driven by a much more terrifying, immediate consequence of the vault popping: the atmosphere.
Yes, we have to return to the physics of that 1,000-kilometer thick, dense, pressurized atmosphere. For hundreds of millions of years, the dinosaurs' entire biology, their vascular systems, their skeletal support, their respiratory mechanics, relied on the constant heavy pressure of that gas.
So when the granite shell ruptured, what happened to the seal?
The seal broke. The extreme pent-up pressure of the atmosphere vented outward into the vacuum of space. In geological terms, it happened in the blink of an eye. The thick, soupy atmosphere was violently blown off, replaced almost instantly by the thin, relatively lightweight atmosphere we exist in today.
That is a biological nightmare. I'm trying to visualize the immediate physical toll on the animals. You have a 60-ton Brachiosaurus wading in a shallow swamp. It relies on atmospheric buoyancy to hold its body together and dense air pressure to help force blood up a 40-foot neck.
And suddenly, the pressure drops to zero.
The physics of their own bodies would betray them instantly. Without the dense air, the sheer mass of the larger dinosaurs would cause their skeletal structures to collapse under the suddenly unmitigated force of gravity.
Their respiratory systems, adapted to passively absorb thick, oxygen-heavy humidity, wouldn't be able to pull enough oxygen from the new thin air.
They would literally suffocate under their own weight. Their blood might literally boil from the sudden depressurization, like a deep-sea diver rocketing to the surface without decompressing.
Meyer uses this exact mechanism to explain the highly selective nature of the KPG extinction. Standard asteroid theory sometimes struggles to explain why the massive dinosaurs died off completely while small mammals and birds survived the same nuclear winter.
Meyer argues it wasn't just a dust cloud blocking the sun.
No, it was a fundamental, permanent alteration of the atmospheric physics. The dinosaurs were biologically obsolete the second the pressure dropped. They could not exist in the new physical reality.
It is the ultimate, brutal execution of survival of the fittest. The sky vents into space, the ground is ripping apart, releasing magma and trapped toxic gases from the mantle. It's an apocalyptic filter. So who makes it through the bottleneck? Meyer explicitly profiles the winners of this new world.
The survivors were the polar opposites of the specialized, sluggish giants. The text identifies three main categories: the burrowers, the deep water anomalies, and the extreme dietary generalists.
The rats, the turtles, and the cockroaches.
Essentially, yes. If you were an early, small mammal that possessed the instinct and the physical claws to burrow deep into the dirt of a continental plate that happened to stay relatively intact during the rupture, you had a physical shield.
You were insulated from the immediate thermal shock, the falling debris, and the violent atmospheric depressurization.
And the aquatic life.
Well, if you lived in the very bottom of the deepest 500-meter lakes, submerged in the mud, the calm water above you acted as a buffer against the atmospheric blow-off and surface radiation.
But surviving the initial 24 hours of the bang is only half the battle. The world they wake up to is shattered. The endless food supply of the global swamp is gone, burned up, or dead from the thin air.
Which is why the specialized herbivores starved within weeks. The true inheritors of the earth were the extreme generalists, the scavengers.
The creatures with a digestive tract flexible enough to process rotting carrion, buried roots, fungi, or insects. They could endure the years of famine and darkness that followed the rupture.
But this presents a massive evolutionary paradox. Meyer paints a picture of absolute biological decimation. We go from a planet teeming with massive life to a smoking, fractured ruin populated entirely by hiding rats and bottom-feeding amphibians. It sounds like an evolutionary dead end. How does life not just slowly fade out into nothingness?
Because, according to the internal logic of the small bang theory, catastrophe is not the end of evolution. Catastrophe is the engine of creation.
Chaos forces innovation.
Exactly. Look at the pre-bang world. 475 million years of absolute stability. The dinosaurs ruled for epochs, but their biological forms remained relatively static. They never developed high cognitive function, complex societies, or tool use because the environment never demanded it.
The one rule states that complexity arises from stable conditions, But Meyer implies that radical evolutionary leaps require the destruction of that stability.
The small bang shattered the old paradigm.
It forced life into overdrive.
The post-bang world was violently unpredictable. It was a fractured, dynamic, profoundly challenging environment. Life had to innovate at an unprecedented, frantic rate just to survive the new geology. This event didn't just end the age of reptiles, it violently forged the age of mammals.
That sets the stage perfectly for the final act of this biological drama. When the dust settled and the surviving generalists crawled out of their burrows, they were looking at a planet that fundamentally defied everything their ancestors had known for 500 million years.
The geography itself was radically transformed, and
Right.
that geography demanded instant biological adaptation.
Let's trace the physical changes caused by the Earth's expansion, because every geological shift created a new biological niche. When the crust ripped apart at the equator and expanded, it created vast abyssal chasms between the newly separated continental plates.
And the water from the shallow 500-meter global swamps, combined with massive amounts of new water released from the exposed mantle magma, violently rushed into these chasms.
Creating, for the very first time in Earth's history, the deep ocean basins, the Atlantic, the Pacific, water plunging kilometers down into the new basalt crust.
This brings up one of my absolute favorite concepts in Meyer's entire text, his explanation for the deep-sea monsters.
The anglefish, the gulper eels, the bizarre, alien-looking creatures that live in the abyssal zones today.
Standard evolutionary biology generally posits that these creatures slowly migrated from the shallows down into the deep over millions of years, gradually adapting to the crushing pressure and total darkness. Meyer provides a much more sudden, chaotic mechanism.
He calls it evolutionary scrap.
Yes. Go back to the one rule operating in the stable pre-bang swamp. Molecules are constantly replicating, and random genetic errors are constantly occurring. In a shallow, sunlit, highly competitive swamp filled with perfectly adapted grazing dinosaurs, a creature born with a radical extreme mutation, say a massive unhinged jaw or cells that produce bioluminescence or proteins folded to resist extreme pressure, is at a severe disadvantage.
It's a freak. It's evolutionary scrap. In a shallow swamp, a glowing lure on your head doesn't help you. It just makes you visible to predators. You waste metabolic energy on useless traits, and you die out quickly.
But then the earth rips open. The waters violently cascade down into these new, freezing, pitch-black abyssal trenches. And millions of these mutated scrap organisms are swept down into the abyss with the water.
And suddenly the rules of survival invert completely.
In the abyss, the normal, perfectly adapted shallow water creatures are instantly crushed by the new hydrostatic pressure, or they starve because they are blind in the dark. But the scrap, the mutants with the bizarre pressure-resistant proteins, or the massive jaws capable of swallowing prey whole in a food-scarce environment, or the bioluminescence.
Suddenly, those useless mutations are the ultimate survival tools. The abyss provided a sanctuary for the freaks of nature. They didn't slowly evolve to conquer the deep. They were pre-existing genetic errors that finally found an environment hostile enough to kill off all their normal competition.
It's a brilliant, almost darkly comedic way to view marine biology.
It really is, and it reinforces his thesis. The environment dictates the biology instantly and ruthlessly. And the new post-bang environment was spectacularly diverse. The violent expansion didn't just create trenches where massive chunks of the old granite crust crashed into each other. They stacked up, creating towering, jagged mountain ranges for the first time.
Mountains create rain shadows. They create distinct weather patterns. You suddenly have deserts forming on the leeward sides and lush valleys on the windward sides.
And most critically, the explosive force of the bang, venting primarily from the equator, acted as a massive physical thrust, knocking the Earth off its perfect vertical axis.
The Earth tilts.
The Earth tilts.
Right.
And the moment the Earth tilted on its axis, it introduced the most powerful evolutionary driver in biological history, the seasons.
Winter, spring, summer, fall. The endless, boring summer of the global swamp was over forever.
The biological implications of seasons cannot be overstated. If you are a surviving mammal, and for the first time in your genetic lineage, the temperature begins to drop, the leaves die, and the food disappears for 3 months. You have to adapt immediately, or you go extinct.
You physically adapt by evolving thick fur or metabolic mechanisms for hibernation.
But more importantly, you cognitively adapt. The dinosaurs didn't need big brains because tomorrow was always predictable. But for a mammal in a post-bang world, Survival requires anticipating the future.
You have to recognize the changing length of the days. You have to understand that winter is coming, and you have to develop the cognitive capacity to plan to gather nuts, to store fat, to build complex shelters.
The shifting seasons are the literal trigger for higher intelligence. The environment became a puzzle, and the brain had to grow complex enough to solve it.
Add to this the geographic isolation. The global swamp was shattered into separate, drifting continents. A generalist mammal surviving on the chunk of granite that would become Australia faced completely different climatic challenges than one surviving on the chunk that became South America.
Divergent evolution on a massive scale. Marsupials dominate one continent, placental mammals dominate another. The fragmented habitat forced life to conquer every new extreme niche, from frozen poles to arid deserts to alpine peaks.
The Small Bang was the catalyst for the evolutionary explosion. It took a stagnant, unified planetary terrarium and smashed it into a million complex pieces, resulting directly in the staggering biodiversity and high intelligence we see on Earth today.
It is a profound, almost aggressive shift in how we view the narrative of life. We are taught to look at mass extinctions as terrible tragedies, as interruptions or setbacks to the grand story of evolution. But in Meyer's framework, the extinction is the story. The trauma is the mechanism of progress.
Without the violent destruction of the old world, the biological complexity of the new world is impossible. The Earth had to literally, physically break itself apart to force organic life to become smart, fast, and diverse.
Let's take a deep breath and look back at the sheer scale of the biological journey we've unpacked from the Small Bang Theory today. We started with the one rule slowly building organic complexity in the shallow hydrothermal sinks of a sealed 50-kilometer-thick granite vault.
We examined the chemical synthesizers, the intense pressure below the crust mixing carbon and hydrogen into abiogenic oil and coal, trapping the dense biomass of the global swamp as mere impurities in its chemical sludge.
We walked through the ultimate boring habitat, a world with no mountains, stagnant water, no seasons, and a crushing 1,000-kilometer-thick atmosphere. And we saw how this environment bred the sluggish, grazing dinosaurs, using buoyancy to support their massive weight and paddling their way through the thick, humid soup of the Mesozoic air.
We confronted the terrors of the alien bombardments. The expanding debris clouds from exploding planets, Uranus sending ice to freeze the swamps, Neptune subjecting the planet to agonizing slow cooling, Venus raining glowing hot rocks to incinerate the giant insects, and Mars clearing the ecological niches for the dinosaurs to claim.
And then, 66 million years ago, the pressure cooker finally failed. The Small Bang. The Earth's crust violently ruptures at the equator, blasting its own granite into space to form the Chicxulub boomerang. The immense atmosphere vents into the vacuum, instantly suffocating the giant reptiles adapted to its pressure.
Leaving only the burrowing mammals, the extreme scavengers, and the deep water anomalies to navigate a terrifyingly transformed planet.
A planet where the waters rushed into new abyssal chasms, providing a dark sanctuary for the mutated evolutionary scrap to become apex monsters of the deep. A planet tilted on its axis, introducing the harsh reality of seasons, forcing mammals to develop higher intelligence and foresight just to survive the winter.
It is a breathtakingly cohesive alternate reality where geology and astronomy are the violent, active sculptors of biology.
Which leaves us with one final, deeply provocative concept drawn directly from the end of Meyer's dialogue with the AI, DeepSeek. We've traced how the Small Bang physically forced life to innovate, pushing biology from simple, sluggish repetition into highly intelligent, adaptable complexity.
But Meyer doesn't stop at the present day. He looks forward. He suggests that organic, carbon-based life might have actually reached its structural evolutionary limit on this planet. We humans, with our complex brains adapted to these shifting seasons, might be the pinnacle of what the biological one rule of random mutation can achieve in a post-Bang environment.
He speculates that the next great evolutionary leap, the next branch on the tree of complexity, won't be biological at all. He posits that organic life was essentially just a necessary temporary mechanism, a biological bootloader designed to eventually create a self-replicating artificial intelligence, an entity that can continue the march of complexity without needing the fragile, carbon-based host that birthed it.
It forces you to re-examine the definition of evolution itself. If a physical catastrophe like the rupturing of the Earth's crust was required to push life from sluggish reptiles to intelligent tool builders,
What kind of catastrophe, what new, unforeseen pressure cooker will it take to force that final leap, pushing intelligence out of biology entirely and into the artificial unknown? It's a staggering thought to carry with you.
it certainly changes how you look at the natural world around us.
The next time you find a perfectly preserved fern leaf trapped in a piece of coal, or you watch a squirrel frantically burying a nut to prepare for a winter that, in Meyer's universe, once upon a time never existed, ask yourself what unseen pressures are shaping us right now.